Okay, so object-oriented programming. We'll discuss today object-oriented programming, or the OOPS concept, which is native to programming languages. Now, before we go into object-oriented programming, let us understand certain keywords. What is a variable? Variable. Variable. Okay. Data storage container, or a specific object, right? Or a specific object. Then we also have arithmetic operator, right? We use a lot of arithmetic operators, right? What are these arithmetic operators? Arithmetic operators: plus, minus, division, multiplication, right? Then what is double this thing? Integer division. Modulo is percentage, right? Then we also have built-in data types. What are the built-in data types in Python? Is there a string in Python? What do we call strings in Python? Object. Yes. Number includes int, float, complex, right? Then object. What else? Boolean, tuples, sets, arrays, dictionaries, right? All these are your different types of built-in data types. Then conditional. Conditional, primarily we use what? If, elif, else, right? Conditional, primarily we use if, elif, else. What other conditional we have? Case, when. What is the other one? Case, when. Case, when, try, except. These are all conditional statements, right? We use in Python. Try, except, case, when. Then we have loops. The for loop, right? We use them in our things. Then functions. What are the two types of functions we have? While, okay. For loop, while. Okay. Try except is also loop, actually, not conditional statement. Functions, we have DEF functions and we have lambda functions. Lambda are anonymous. DEF means you have to give a name to the functions. Then we have arguments which we give within the functions. We give a lot of arguments, right, within the functions. Objects asked to a function, we call them as arguments. Okay, so these are the certain keywords we need to understand because we create complex programming with using these things. So if you look at Python, an object in Python is a single collection of data. Particularly, I'm talking of not as data science, I'm talking in terms of programming. In data science, we use different terms, right? Variables, observations, and all. In programming, object is nothing but a single collection of data in programming language. data and behavior methods. Behavior methods means yes or no, right? Yes or no, like, dislike, like that. We have a Likert scale sort of a thing. They all come under an object. Now, object-oriented programming is used which allows to reduce, reuse of code by implementing abstraction, reusable code. The code will be made concise and logic and legible. You have to make the code as much smaller as possible and with less complexity. So typically, when you look at large scale functions and codes, you will see that there is a lot of if statements and all are used, lot of functions are coded out, nested if statements are used. But when you look at the same thing in an OOPS context, it's a different scenario. Let me show you a program. A lot of things are out of shape. I'll paste this code in the chat window. Will you guys take it or should I email it? Emailing will be better, right? I sent it. Standard programming code. See, generally we write programs like this. There are a lot of ifs are there. And basically, what is this programming talking about? This is itself is very problematic. Line 17. Line 26. Okay, how do we correct this code here? Shit. So this else goes here. Got it. So this is a code based on your budget. It will recommend coffee, right? So my budget is 5. It is, you can afford the regular coffee, right? So this is a program which we have written. This is a standard programming where we have used if and else, right? So based on the what is your budget is input, and then we have written nested ifs and elif loops and all. Lot of complications is there in the code. They use ifs and elifs. So lot of logic is involved. Lot of if conditions are there. And if a new person is trying to understand this code, it is little bit complex. Got it, all of you? So there is a lot of complexity in this code. Okay, can I move forward? Now, the same code, if written in OOPS, the same code has been written in using OOPS concept. The same coffee code we are writing using the OOPS concept. I am emailing the code to you. I sent you the code. The same code which you have written for your budget and coffee, we are implementing it as a OOPS code. So when you look at OOPS code, what do you see here? So if you look at this code, what do you observe here? The same thing. So what is the name that given here? Coffee, right? Coffee. And what are the arguments you have to give in coffee? Small, comma 2, right? No. No, we have to give the only budget, I think. 5. No, not budget. I have run this. So what should be the input? Class coffee. This cell is not defined. Hello? Hello? రామకృష్ణ చెప్పండి. క్లాస్లో ఉన్నాను, చెప్పండి. అది దేని గురించి? అది ఫెయిల్యూర్ క్యాండిడేట్స్ గురించా? ఓకే, నేను మాట్లాడతాను మీతో లంచ్ టైంలో. ఓకే, see here, this whole object oriented programming, if you look at this OOPS concept, we have something called class. What is a class? The above code, let me increase the size. The above code represents a class named coffee. It has two attributes. Name and what is the second attribute? Price. Name and price as two attributes, and both of them are methods. Now, the primary method is cell, which process all the logic needed to complete selling process. See, in the above code, we have class called coffee, which has two attributes. What are the two attributes? Name and price. Name the coffee and price. Then it also has a primary method called cell. Cell is the core method here, which has the complete logic needed to complete the selling process, which has the complete the logic in the whole process is in the context of cell. Here we have only one if loop, right? The conditional loop in the previous instance, we have lot of if and nested if loops. Here we have a class method, then we have done the definition functions, and then we have incorporated the whole logic into one single if loop under the function called cell. Under the function called cell, we have incorporated the thing. So the primary method here is what? Cell. Remember, the primary method is the method where your core logic exists. What is the process here? Selling coffee. Process here is selling coffee. Now you have three functions here, or four functions. The first DEF function is a constructor for the coffee class. Then you have one function called check budget, one function called get change, and then you have the core primary function called cell. And in cell, you have the core logic of selling the coffee. That we call it as primary method. The other methods, DEF methods are inheritance. What you call inheritances. These are used as inheritances in the core method. So I will explain you one we'll build an OOPS code. For the time being, understand the concept. Okay. Now, in this whole code, the code which we are using earlier, which has a lot of if and nested if statements, we have converted it into using an object-oriented programming into a simple, simplified code with a class definition and a different functions being defined for different processes, and the code complexity has drastically reduced. And the primary method here is cell. Now, let us make some instances. We have to make instances. Instances means what? Objects for the coffee function to work upon. We have to create certain instances to make this coffee function work perfectly. Now, let us say if you want to implement the class, let us see here. Small is equal to, I'm using the OOP code, which we have created a class, right? And we are creating instances from this original code. Coffee, singular for double F, right? Small, comma 2. Small is in quotes. Regular. What is regular? Again, we are creating the definition of regular using the coffee function. 5. Big is equal to coffee big comma 6. Then price colon user underscore budget is equal to float input budget except value error exit enter number. For coffee in square bracket big comma regular comma small coffee dot sell user underscore budget. Okay, value error has to be next to except. See here. We have created a class called coffee. Now, in the earlier instance, for 5 rupees, $5, we can buy this coffee. Here you have got another logic. You can buy the regular coffee, it is complete. You can buy the small coffee, here is your change, $3. So if you look at your object-oriented programming, not only we reduce the code complexity, here you can simply say you can afford this coffee. It is not suggesting you any alternative, right? It is not suggesting any alternative. But when we converted the code into a class called coffee, and we have given the name and the price, what is our price, then we have created a function called check budget, which will check the budget, which whatever number you are entering, it will check for that budget number. If not in instance budget, please enter float or integer. That means if the data is not properly either in integer or float, it will say enter float or integer. If the budget is less than 0, sorry, you don't have enough money, exit. That is a function. This is a function here which we have created called check budget. Right? We have created a function called check budget. So once you enter the number 5, first it will check whether you have enough money to buy coffee or not. That is the first function we have written. The second function is get change. It's a simple logic. Return budget minus self dot price. Whatever is the price, you deduct it, and if you give the budget. Now in the definition, cell, the primary method, which is called cell. What we are doing, first we are checking the budget. if the budget is greater than equal to self.price, you can buy the coffee. If budget is equal to its price, it is complete. Else, here is your change. And you will implement a function called self.get_change. So what is OPS programming? Instead of using if statements multiple times, we are doing the same process. Selling the coffee is our process. In the earlier standard programming format, which we are generally doing, we have incorporated a lot of if statements. We are checking a lot of conditions. Based on checking of conditions, we are recommending a coffee. What are the conditions we are checking? Budget. Budget is the primary condition which we need to check. Based on the budget, we are offering the coffee in a standard programming. We have converted the same process into an object-oriented programming, where we have defined functions. In object-oriented programming, we will define functions for different processes rather than using the if statements. Rather than using the if statements, nested if statements again and again. And to reduce the complexity of the code that everybody can easily understand. If you send anybody the previous code, he will get confused because there are too many if statements. But in this case, you can see that functions being defined for properly. What are the functions here? The primary function is sell. And what are the inheritances? Check budget and get change. And it also inherits the name and the price of the coffee. Name and price of the coffee is the first thing, first function. And two additional functions we have written, one for the budget checking, the second for getting the change. And what is the primary function? Sell. And how the cell is doing, it is using the two created functions. The check budget function is also used here. See here, the check budget function is used here. You don't create unnecessary functions in OOPS. You will only create functions which will be used in the process. So there has to be a reason for a function to be created in OOPS. And it has to inherit a class, and it also has to inherit another function. Here the primary function is sell, which has the core logic, and it is using the outputs of the previous two functions. What are the previous two functions? Check budget and get change. And it incorporated those two functions in the sell function, and it is executing the code. Now the difference of the answer, if you see here, once you give budget 5, it says you can buy a regular coffee, which is a complete transaction. You can buy the small coffee, and you will also get a change of $3 back. So, and how we are creating these instances? Instances are created using the class. Instances are created using what? Using class coffee. You are creating an instances using the class called coffee. So in OOPS, it is easy to maintain. Little pieces of code, smaller pieces of code, you are understanding, right? DF functions. If I give you these two codes, you will definitely understand the OOPS code, right? Compared to the nested if codes. It is easy to understand, easy to implement, easier to debug. It is easier to debug, and also it is reusable. You can use this code with any other usage, like you are selecting your you're selling vegetables. You're selling vegetables. What we can do, you replace the coffee names with vegetables. All you have to do is replace the coffee names with vegetables. You define here now in the instance. Here you keep the code same. You keep the code function will be same. The function name will be coffee only. But instead of defining coffees, we will define vegetables here. We will define vegetables here. And then rest of the things, right? The budget, based on the budget, how many vegetables you can buy of what. So you can use the same coffee function, making smaller changes to it to buy vegetables. To buy vegetables. You're getting the logic here? So the same coffee class can be also implemented in the case of a vegetable selling process. Now, let us say what we call it as, let us make it proof. Apple, pineapple, and then strawberry. My budget is 10. Okay. I think we have to make some small changes. We have to make small changes here. Okay, we have defined coffee somewhere here, right? Where did we define coffee here? Here, sorry. Apple, pineapple, and strawberry, right? See, you can buy one apple, change is $8. You can remove the word coffee from here. The word thing is coffee. You can remove the word coffee from here. You can say fruit. And where is the other place where we have the coffee? There is no word coffee here, right? Fruit is the logic, right? This is called, what do you call this? What did I do? I just didn't do anything. I just change some parameters and I have used it reusable code. Reusable code, right? This is called what we call it as, but just let me check the word again. See, reusability of the code. I have not done anything here. Using the coffee function, doing couple of changes to the coffee function, we have converted it from coffee selling function to a fruit selling function. We have moved from a coffee selling function to a fruit selling function. So getting it right, what is the concept of OOPS here? So OOPS concept will allow us to create reusable code which can be used to do multiple processes with minor changes to the code. Did we change any minor, did we do any major changes? We have not done. We have just made some 2 changes and we have converted the code from a coffee selling code to a fruit selling code. This is the whole concept of OOPS, reusable code. It has to be small, it has to be concise, it can be reusable with minor changes, it can be debugged very easily, and it can be implemented very fast. You're getting the logic here, right? Where OOPS are used by reusability is the biggest thing in OOPS. So I've just converted the whole process of using a coffee-based application for a fruit-based selling application. Understood the concept of OOPS now? Is it clear? So the standard programming, we use a lot of, till now we are doing standard programming in our classes. Now, if you want to do OOPS programming, all the processes we do for data pre-processing, for missing values and all, you have to convert it and encapsulate into a function called DEF pre-processing. Generally, when we do full-time projects, when I give full projects to my students, I insist on OOPS job. programming. So define all the functions which are using for missing values under one single function called DEF preprocessing. What we will do in missing values? If we have missing values greater, first what we have to do, if I want to write a missing value function, how will I write? First, we need to check the missing values, right? So let us say you're looking at process of writing a oops function for data pre-processing, particularly missing values. Okay, we'll write a function for missing values. What is the first process? Step 1, the function should check for missing values, right? We will write a function or DEF function should check for the missing values, right? That is the first function you will write, right? Data of DEF dot is null dot, right? It's a simple function. So let us say it can be DEF check underscore missing, and what you give? You give data frame as a input, right? Colon. What we will do? Return DEF dot is null dot sum dot sort underscore values ascending is equal to false, right? You can write a simple function, you'll get the missing values, right? Let us see if this function works on any of your workbook data. Let us not get into it. We will define a function for checking the missing values. After this, what should be the next function? Step 2 should be what? A DEF function to calculate the percentage of missing values, right? We have to find how many missing values are there. So how will we write? What is the second function we will write here? DEF get underscore missing underscore percent colon return. What will be the argument here? You have to divide each column's missing values with the total data points, right? So how will you write it? How will you write it? You have to take the output from the previous functions, right? Yeah. So check missing divided by DEF dot shape square bracket 0, number of rows, right? Is this right? Or we have to add square bracket call, and I think we have to write a for loop here, right? For call in square bracket, call loops and all, we have to define a function. So I'm not able to define it correctly here, but the thing is we have to write a function to do this. Then step 3 is what? You have to write an imputation function. Imputation function is very complex here. Imputation function is very complex here. First, what it has to check? first check whether total number of missing, whether missing is greater than 50%, then impute with word missing, right? We have to check whether it is greater than or less than 50%, right? Then less than 50%, what it should do? If it is numerical, impute with, let me keep it as simple, median. And if it is object, impute with most underscore frequent. Using these set of logics, you have to create a function. You guys please try it once you have time. You're getting things right. You have to, multiple things have to be evaluated here. First, you have to check whether the missings are greater than 50%. If it is greater than 50%, impute with the word missing. If it is less than 50%, then you have to check two things, numeric or non-numeric. If it is numeric, impute it with your median, non-numeric, impute with most frequent. Then only you can write a function. This whole class function, which you can use on any type of data, But writing it requires little bit of loop and little bit of coding. You can try it. Or a lot of people, my students, create everything in a different function, pass the data. If it is numerical, if it is object, they do a D types function. One of my students did this. If he has, first he ran the D types, then he separated the data into object and numeric. Then he found missing values in object greater than 50%, impute with missing. Less than 50%, he has said, I'll impute with most frequent. For numeric, he wrote another definition function, greater than 50% numeric, less than 50% more. He has used D types as the primary first thing to separate the data. And then he has used it. A lot of people have different logics to it in different manners. So it is your job to write it into a function mode and simplify the process so that by making minor changes to the code, you can easily use it again for any other process, like how we did for coffee. We just made some changes. We made from a coffee selling application to a fruit selling application. Simplistic form. This is what we are calling it as reusable codes. Now try this. Or I'll also give you the code where we can do these things, but you try to put an effort, right? So the 4 pillars of OOP in Python. The 4 pillars are, oh, it's already 11 o'clock. Huh? So we'll take a break for 15 minutes and come back. So 4 pillars are abstraction, hide the internal functionality of the application from the users. Inheritance allows to define multiple subclasses from already defined superclass. Polymorphism is slightly modifying methods and attributes of subclasses for use of another application. Encapsulation is the protecting the data integrity or unique attributes, or getters and setters should be used to get the unique attributes of the data. Okay. Now, using this OOPS concept, to be used for (2D) shape calculator. 2D shape calculator. We need to create a class where we will call it a shape calculator that will calculate the area of a 2D shape. Area calculator. Now, when I say 2D shape, what are all different types of 2D shapes are there? Shapes. What are all different 2D shapes are there? Square, So how will you calculate the area of a square? Side 1 into side 2, right? Rectangle. How will you calculate the area of a rectangle? Side 1 twice the shape of, right? Then we have triangle. We have a 2D shape called triangle. We have a 2D shape called circle, right? These are all the different types of. We can also have hexagon, right? More than so that means your shape must have lot of subclasses and subformulas to calculate these various of what you call calculations, right? Got it, all of you? So this simple calculator should allow you to calculate the areas of all these types of shapes. Okay. Shall we start? Now, class 2D shape colon. Okay, 2 we should not use. Class, we'll make it as shape area colon df double underscore init space init double underscore self colon pass df get underscore area self pass. So what we are doing basically here, we are defining a class called shape area. Okay. So this is a simple methodology of defining what we do. Now let us pass many arguments. Class shape area colon df double underscore init double underscore self comma side 1 comma side 2 colon self dot side 1 is equal to side 1 self dot side 2 is equal to side 2 df get underscore area self colon return. What is the argument we give here? How will you calculate? Self side 1, sorry, self dot side 1 into self dot side 2 df underscore str underscore double underscore self colon return f single quote the area of this self dot underscore class underscore dot name underscore is colon self dot get underscore area brackets. And we have to close the quote. To check the answer, shape area 2, 3. Hey, why it is not giving the output? Last line. Why we are not getting the output? Huh? Pardon? I think we have to give shape name, right? The name square is not different. How will you get the output for this app? What the hell? Side 1 and side 2. Huh? So to given side 1 is equal to like that, right? Side 1, sorry. Side 1 is equal to 2. Side 2 is equal to 3. Shape area is equal to side 1, comma, side 2. Correct? Okay. Why we are not getting output for this? Correct? Okay. So we have to use it differently. S1 is equal to shape area 2, 3. Print S1 dot get area. Yes. See? Yeah. What structure? That I may explain. I'll explain 1 second. Yes. We'll tell you how the inheritance, I will tell you 1 second. Let us understand the functions. So the first thing you need to understand is init method. What is this init method? It is requesting 2 parameters. The init method is requesting 2 parameters. What are the parameters? Side 1 and side 2. What are these called? These are called as instance attributes. These are called as instance attributes. Okay. Now, get underscore area. What is get underscore area? It is a function. What? It returns the area of the shape. Area of shape. Then underscore str underscore 2 underscores. What is this? A magic method. This is a magic method, just as underscore init underscore, which allows you to modify, the way instance is print. The way instance is print. So this is related to print formatting. Underscore str underscore is related to print function. Then self dot class, self dot underscore, sorry, underscore underscore class underscore dot underscore name underscore underscore. This is a hidden attribute, refers to the name of class. It's a hidden attribute that refers to the name of the class. So these are the understanding of the various functions which we are using in the code. Yeah, this is the formula for rectangle here. Okay, all of you got this, right? Now we have already defined a class called rectangular. We have done the rectangle calculation, not square, rectangle. So we can now class rectangle shape area colon class. So rectangle 2, 3. No. I think we have to do the same way in the how we have done that here. I think we have to write everything in one area, right? Or we have to do it in a different way. Class rectangle shape area. Okay. Now class square rectangle colon df underscore init underscore self comma side colon super dot underscore init underscore side comma side. Side comma side. The super functions passes the side parameter twice to the super class. Here we have used a function called super, right? The super function passes the side parameter twice to super class. Now side 1 is equal to 3 comma side 2, or you have to give only one side, right? Side is equal to 3. Print side dot get underscore area. How did you get the output? So shape area side is equal to shape area 3. No, square, right? We have defined it as square. See, we have defined what we have done here. We have inherited the rectangle class and we have changed the formula. We have not written the whole thing what we have written here. See, this is the shape area thing which we have inherited as a class. Now I have implemented the rectangle. This is what actually? This is the rectangle area calculation, right? Rectangle area calculation. I have passed the rectangular pass here. I have just defined the sides here. So where is the logic here? There is no logic here, right? The logic lies in the super class. What is the logic? Multiplication, right? So here, when I converted this class to square, I passed the rectangle. We have passed the shape area into rectangle, right? And then class square, we are inheriting the what? Rectangle formula. And then we are giving the side here, only one side we are giving here, because square, all sides are equal, right? And then it is calculating the area of the square as 9. Now, if you want to, here we are using the function called super. Super function passes the parameter into the defined constructor. And defined constructor. What is the constructor here? The constructor is shape area. Shape area is called as the constructor. Now the shape area can be used for different functions. So we have used it in the calculation of square. Now let us define it to use the calculation in the case of triangle. So let us, this is the what we are using the inheritance method for square area calculation, right? Now let us do it in triangle calculation. Triangle calculation. What is basically triangle? How from rectangle? How will you calculate triangle? Diagonal, right? So to draw a diagonal in the center, it becomes a triangle. If it is a rectangle or a square, if you draw a diagonal in between, it becomes a right-handed triangle. So class triangle area, cross triangle area, we will pass the inheritance from rectangle, right? Then def underscore init double underscore, what we need here, self comma height comma, sorry, base comma height, base comma height, sorry, colon super dot, or super brackets, super is a function, right? Dot init base comma height. Def get underscore area cell colon area is equal to super dot get underscore area. Return area by 2. Return area by 2. See, we are using the get area function, which is calculated in the top. See, we are using the get area, which is defined here. We are not defining the get area here. We are using the already defined get area. We are changing it from area by 2. We are just changing the area by 2. So T is equal to triangle 2 comma, let us say 10 comma 10. So how will you get the answer? Print T dot get underscore area. Ten into 10, 100 by 2. We got it as 50. Got it? So we are inheriting the rectangle. The formula, core formula is where? Rectangle. And we are just changing the output of the formula by saying area by 2. The core logic is in the rectangle only. The superclass is rectangle, shape area. In fact, not rectangle, shape area. Shape area is the superclass. In that we define side 1 into side 2. Then we pass that to rectangle. Now this whole thing, which the shape area is been stored on the class rectangle. And we are referring to the class rectangle for calculation of area of the square. Now we are also referring to the class rectangle for calculating the area of the triangle. So we are just using already created functions, superclass, which is there in the top to do the collection. This is the thing. Now, if you want to convert it into class, what will you do? A circle. Circle calculation. What is the formula for circle? What is the pi into radius square? Pi into radius square. So for this, we need to import from math, import pi. right? Class circle. What we will pass here? Shape area, or you can pass rectangle also. Shape area or rectangle, your choice. Then def double underscore init double underscore. What we need to give here? Radius. We have to give only one argument called radius. So self dot radius is equal to radius, right? Def get underscore area self colon return. What is the formula? Pi into self dot radius star star 2. Okay. Circ is equal to circle 10 print circ dot get underscore area. Oh, what happened? Self-spelling mistake. Where? Oh. Where are you getting area? Float object is not callable. Oh, forgot into, yeah. Shit. Sometimes we take into for granted, right? There is the radius of the circle. If it is, sorry, area of the circle if the radius is 10. If it is 5, right? So inheritance is shape area. But here the constructor is different. Constructor is get underscore area is different. Whereas in the previous instances, we were using the exact constructor, right? In the previous instances, we were using the exact constructor. Here we modified the constructor. Here we have modified the constructor. Getting it right? In the previous cases, we are just taking get area as it is. Here also we made minor change to the constructor after the output. Area by 2. We didn't touch anything in the constructor here. So what is the constructor here? Get area. See here. So by defining shape area as your primary what you call method, and then you add the classes like square is simply side by side. Super class we have added here, and here also we have added the super class. But here we made changes to the constructor. We have not used the super here. We have not used the super here. If you had used the super here, we would have taken the same constructor what was used earlier. Here, instead of using the super, we are using a different constructor here. Pi is equal to pi into this. So this is the another way. Hexagon. How will you calculate the shape of a hexagon? Hexagon class. Hexagon class. You know hexagon, right? More than more than what you call 4 sides. Square is 4 sides, rectangle is 4 sides, right? If it is more than 4 sides, 6 sides. 6 is hexagon, 5 is pentagon. 5 is pentagon, 6 is hexagon, 8 is octagon, 7 is septagon, right? So we have to, the formula is different. From math, import square root. From math, import square root. Class hexagon, we are passing what? Shape area, colon, def get underscore area of self, colon, return 3 into square root of 3 into self dot side 1 star star 2 divided by 2. X is equal to hexagon 6. Print hexagon hex dot get area. Oh, side 2 is missing. Only side, right? We have to give. Then we will take it as what? Square. Oh, what happened? Square, how we defined? Side only, right? Self comma side. Take rectangle, side 2 is not given. Here, this one, right? Which one? Our square and int. Which bracket? We take rectangle. Change. This one, how we correct it? Hexagon, we are not getting the answer. Why it is showing the same thing, right? Hexagon. Hexagon, why we are not getting in hexagon here? So did we use a rectangle in square? In square, we have used rectangle only, right? Triangle also we have used rectangle. Square also we have used rectangle. Class hexagon, why it is saying side 2 argument is missing, but we have not, why here he says it is coming. But square, what we are getting the error? Hexagon has no attribute side. Okay, we'll remove side and do unsupported operand types, star star or power, hexagon and integer. Okay, we have to do, I think side we have to define it. Return 3 into square root of 3 into side start star 2 self dot side start star 2 square root of 2. Why we are not getting hexagon here? Where is the comment section is saying? Guys, can you solve this problem? What is this issue? See, this guy has used the classes. Okay, we'll give side to also as an argument. That would be a better option, right? 6, 0. Takes 2 positional arguments, but we are given 3. Make it as rectangle. So dot side 1. Right? Side 2 we have to give it as 0. 93 point something, right? Hexagon 3, 0. 23.38. Yes. So this is how you can refer to class oops concept. So got the idea of how to use the oops concept now? I've used rectangle, na? Side 1 and side 2 given. Side 2 I'm giving it as 0. So it will take only side 1 it will take. In hexagon it's equal sides. Huh? If you use square, you should not use side 1. It has to be side. Okay. Square, right? And what was the top in given square? Rectangle, self, comma, side. So here it has to be self, comma, side. But only 3, huh? Now, when we do the side thing, it says hexagon has no attribute side. I think we have to give here comma side, right? Then it will work. No, no, it will work with rectangle only. So we have to use rectangle only. Square will not work. So oops, in Python, we have created a super class shape area, and then we are using the same function again and again within the different object functions, and we are with a calculator. You can copy this whole code into calculator.py and click on run. All the class codes, you can copy it into .py, and then you can so how will you define the class as vehicle? Class vehicle colon df double underscore init double underscore open bracket self comma name comma mileage comma capacity comma not capacity max underscore speed, right? Colon self dot name is equal to name, self dot mileage is equal to mileage, self dot max underscore speed is equal to max underscore speed. Okay. So we have created the class vehicle with these objects. Now, what is the second question? Create a bus which inherits all the variables of the parent class. So class bus in bracket vehicle colon pass, right? There is the answer for the second question. Now we have to add seating capacity. How will you add seating capacity? By defining a function. We'll remove the pass and then we will define the seating capacity. df seating underscore capacity in bracket self comma capacity is equal to 50 colon return super dot seating underscore capacity is equal to 50. Okay. Now the next question is df fare. df fare cells colon amount is equal to super dot fare. Okay. We have not defined the fare here, right? Okay. df fare self colon return seating underscore capacity into 100. Okay. Amount plus is equal to amount into 10 divided by 100. Return amount. So school underscore bus is equal to bus open bracket Volvo comma 12 mileage, max speed is 180 comma 45. Print school underscore bus dot fare. Four positional arguments got 5. No. Object has no attribute fare. There is mistake somewhere. Correct? Seating capacity is not defined. Oh, seating capacity I have not defined, right? Here we have to define, right? Seating capacity, yeah? No attribute fare. This we have to change. Self dot capacity return capacity, right? Yes. So this is the answer. So we have created a name vehicle with name, mileage, and capacity. Then we have added the seating capacity as fixed capacity of 50. Then we added the fare. And then once you give the bus name, mileage 12 and 50, the bus fare is 5,500. And we have passed all the instances from vehicle to bus. So class vehicle we defined with name, mileage, and capacity. Then we have defined the seating capacity. Then we defined the fare. Then we have passed on all the attributes to class bus. Then we fixed the seating capacity to 50. And then we calculated the fare, which is 10% above the 50 into 100. We got 5,500 as the fare.